Hello, I'm Andrew Main, and this is the OpenAI podcast. Today, our guests are OpenAI's chief scientist, Jakub Pachocki, and Szymon Sidor. We're going to talk about measuring AI progress, how you determine AGI, and where the next breakthrough might come from.
The model was able to correctly identify that it didn't make progress on the problem.
We started asking very, very seriously the question, like, are we ready as an organization for incredibly fast-paced progress?
When we think about how we shape our research program at OpenAI, we seek to create intelligence that is very general.
I want to first start off by understanding your roles. So, Jakub, you're the chief researcher, chief scientist at OpenAI?
Chief scientist, yes.
Okay, what does chief scientist mean?
So the primary thing I'm responsible for is setting the research roadmap for the company. So deciding what is the technical path we are going to bet on and what is the underlying long-term research that we're going to pursue.
So how about you, Szymon? What do you do?
Random things.
Random things? Okay.
I mostly do IC work. I try to maybe sprinkle of leadership somewhere in there. I try to do what's the very most useful.
Now, you two knew each other before working at OpenAI, right?
Yeah, we went to the same high school.
Same high school?
Yeah.
Were you guys friends?
I think we became best friends when after we left. Like, I think kind of coming to US is the kind of emotional experience that forms bonds.
Right.
I think in high school we were more like colleagues.
What kind of high school produces guys like you?
Also, we went to this high school in Gdynia in Poland. I think we were both drawn there by this computer science teacher, Mr. Ryszard Szubartowski, who's had a great track record before we went there of bringing up computer scientists, programmers, with this like big focus on programming competitions and pursuing excellence in this like one field. Yeah, so I think that was like a very formative experience and a great mentor for us.
Oh wow.
Yeah, definitely. I think Kider was like really going deep on programming. I think it went way beyond like typical high school curriculum. Like there was like graph theory, matrices, and all sorts of stuff like that. I actually hope that maybe with ChatGPT it's a little bit easier for people now to do this kind of deep dives, because without the right mentor and without a lot of work, it's kind of hard to replicate that experience.
I've been using it to explain things like there's the Monty Hall problem where you have to choose which door, and you go into ChatGPT and you say, make a graphic interactive version of this, and all of a sudden you can see it. It can show you the different solutions if you do one thing or the other. I think it's one of these things where I'm excited about the ability of not just to explain in text, but to build multimedia to do things. And it does get into the area of there's not really a measure for that. That it's a use case. You go, this didn't exist before, and we talk about AGI, but we kind of have very loose definitions and whatever. And I'd love to hear kind of like how you would describe it, both from a technical and also like a layperson's understanding of it.
Yeah. Maybe to like address the point about teaching, this sort of like better explanation of some concept or teaching through a Socratic method is like definitely powerful use of ChatGPT, and I think works well with like a teacher like our Mr. Szubartowski. But at the same time, I think like the thing that like he was able to provide was more like kind of emotional support and space, which I think is it will be hard for AI to do alone.
That's a great point. I think that gets lost a lot because I sometimes hear people talk about, AI will replace education. And for me, I had teachers that maybe their facts weren't always right, but their heart was there and they were carried and they answered questions for stuff. And so I think that's a good point, that these are companions to that. And I think that a teacher using these tools can be a more capable teacher.
Yeah.
But so on the subject of AGI though, I want to hear first, like, give me your technical definition of it. Or actually not a technical definition. Give me like how you would describe it to like if you were talking to, a younger sibling.
A few years ago, when we would talk about AGI, it felt like the technology, deep learning, has incredible promise, but at the same time, the concept still felt a little bit abstract, right, and far away. And so I think, whether you talk about human level intelligence, ability to converse naturally, ability to, solve math problems or pursue research, they all kind of felt like in the same space. I think, as the technology has progressed, now we see there's these are actually quite distinct capabilities, and I think we pretty clearly are at the point where the AI is able to converse naturally on a wide range of topics. It is able to solve math problems. I think, getting a gold medal at IMO is something we've long discussed as a milestone on the path to AGI, and that happened. I think solving all the problems on the International Math Olympiad is actually a little bit harder, and I think it's another milestone on the path there. But I think increasingly, we see that these kind of point-wise measures are less adequate, and so we turn to thinking about what is its actual impact in the world. For me personally, the thing that I think about when I think about how AI progress really impacts the world meaningfully, I first think about its potential for automating the discovery and production of new technology. I think we tend to associate kind of new ideas, fundamental technological progress with just human ingenuity, and we measure kind of our progress by this kind of major milestone inventions and technological revolutions, and I think it is just hard to internalize this is possible. It is possible to automate most of this process. It is possible to have a big computer that is coming up with ideas that fundamentally change our understanding of the world, and I actually think that is not that far away. And so thinking about that, what separates us from that and what are the consequences of such technology is my first thought.
I just ordered a little Mac Studio because I want to take the open source model GPT-OSS and I want to just let it run nonstop. Because that idea, just the idea of letting it generate and do stuff 24/7 is fascinating to me. But you're talking about a scale of basically automating science at a huge scale. And so what kind of discoveries, what kind of things do we think might be the first things we could see from that?
When we think about how we shape our research program at OpenAI, we seek to create intelligence that is very general. We drive towards this automated researcher as a priority, but we don't really think of it as let's take this specific domains and let's kind of deploy this technology there. I think that is a way to make faster point-wise progress, but I think the potential for the really big discoveries and the most meaningful technology advancement comes from this generality. Mm-hmm. Although still, I think we see kind of the technology is kind of easier to apply in some domains than others. I think especially in places that combine a large amount of reasoning with a lot of kind of domain knowledge and intuition seem very amenable to these systems. I think in particular we see pretty incredible results on medicine, which is very encouraging. Mm-hmm. I have high hopes about that. I think naturally being a company of AI researchers, we think a lot about automating our own work. I think it is also kind of I don't think it's if AI can indeed reach a point where you can automate AI research, then that is probably a very important thing to automate. And similarly thinking about how it can help with automating research on AI alignment and safety.
I'm obviously impressed by the IMO IOI results. I was actually about to add that in the past when we were talking about the IMO of Jakub, that was a few years ago, and we were still kind of trying to even figure out what our definition of AGI might be. Like one kind of concept we are considering is something like solving all the problems on the Math Olympiad, and why did that feel appropriate is just like, okay, if you have a model with such a superior mathematical reasoning, then it should be able to like disrupt like a bunch of different domains that kind of can be mathematically modeled, right? I mean, I'm in general just I think maybe this podcast is just a good opportunity to kind of like share a little bit more of an inside perspective. I was astounded by the progress. I think so. Sometimes I see those headlines where people say that like, the economic kind of impact of AI is only like 3% or 5%, right? And those headlines are often accompanied by comments like, well, so AI is slowing down, or people are overhyping AI so much, and it's only like 3%. So what's up with that, right? And when I see headlines like this, I remember to like maybe 10 years ago, I was working on natural language processing with deep learning, and back then it just didn't really work. Like I remember Jakub once came to test like one of the technologies we were working on, and that was like trying to detect sentiment of sentences, and he was trying, this movie is bad, correctly classified as negative. This movie is good, correctly classified as positive. And then he would say this movie is not bad, and the model is like, oh, negative.
Yeah.
Right. So that was 10 years ago, right? And since then, like, okay, like we slowly got like we slowly started solving tasks like this, solving tasks like decide, is this word a noun, a verb? That was like sentiment neuron. Then we had GPT-1, GPT-2 started producing like a paragraph of text that made sense, right? That was such a breakthrough. Right now it feels so simple, but back then it was such a breakthrough. Then we had like GPT-3, GPT-4. GPT-4 was like, to me, like kind of like, let's say, my personal AGI moment, because it would sometimes say things that surprised me. And I was like, can this model actually surprise me, right? It's still back then, like ChatGPT for my personal use kind of felt a little bit more like a nuance and kind of like maybe slightly better Google, but like what's the big deal? And then like suddenly we get to deep research and this can actually like answer questions thoroughly, like rarely make things up. That felt useful. And then finally now we have like models that can like compete in programming competitions, which was like a like very hard earned for me personally, and even more so for Jakub, obviously. The pace of progress, just like from the perspective of somebody working on this technology, is like absolutely amazing. So when you see that 3%, like I raised you, like 10 years ago, if we had to quantify it, it would probably be like 0.00001% or something, right? So like really, I think those numbers need to be put in perspective, right? And there is no reason not to believe that like in a year it will be 10%, in 2 years it will be 20, and so on and so forth.
Yeah, I've heard it said that if you looked at like a graph of the economy from, let's say, like, World Wide Web, early 90s forward, and you said point to the internet happening to the economy, you can't find the point. There's no point. You go, oh, okay, Tim Berners-Lee announced this, whatever. And I think AI is a lot like that, where people go, oh, we've only measured this one. Our measures are hard. It's hard to know that, one, who's using it, how they're using it. And you brought up a very good point too about if you've been following it for a while. I remember training like a very simple next character predictor on my computer, and it was terrible, right? One, I'm using a small computer, but even then, and then you got, the sentiment analysis, and you're playing with BERT, and it's kind of just get a little bit better. But then GPT-2 comes out, and I read every single output on GitHub. Every single output GPT-2 came out because I'm like, there is something going on with this. And that's how I ended up working at OpenAI, was because I was this obsessive person about that. And then with access to GPT-3, kept saying, oh, this is really this path that's moving forward. But it's kind of crazy now, because like if 6 weeks go by and a benchmark hasn't been broken, people are like, oh, we hit the wall. And I would say part of the problem, though, is that benchmarks in some ways feel like you'll see modest improvement on them. I've heard some of the benchmarks have problems, that some of them actually have wrong answers, and it's impossible to get 100% if you answer them correctly. But also we talk about the term internally, I've heard people talk about this as, saturation. Do you want to talk about that,
Yeah, I think there's a few issues that we're hitting with benchmarks right now. Yeah, I mean, a pretty clear one is saturation, and that is just the models genuinely reaching a point where, for the kind of standardized forms of measuring intelligence or ability, like they are at human level for a lot of them. If you're kind of like able to perform in amongst the top on this like very hard high school competitions where we have the best competitors from around the world, it just becomes quite hard to like have just like very constrained measurement. Previously when we were looking at this like GPT-1, GPT-2, GPT-3, GPT-4 scaling paradigm, the benchmarks were really they were really just like measuring the rising of the tide. I think now the field has developed a lot of more data efficient ways to train for specific abilities, right? Doesn't mean train on these benchmarks, but you can train models that are like disproportionately good at math compared to their ability to write, for example, right? And so they will do better on math benchmarks, but it's no longer as representative of their overall intelligence in other topics. I think these two issues combined, I think we really have to think about the reward utility of these models, and especially like their ability to discover new insights.
Yeah, I guess that's a thing that sort of kind of gets overlooked, is that you can build a model that's a really good test taker, but that model may not really be that useful for work. Ideally, your model should score well on tests, but just because a model got these scores doesn't mean you're going to find it personally useful. And I certainly think that's a challenge we're at now, where when people say, is a model good or bad, it's kind of like saying, you're trying to create a blanket assessment when there's 100 different use cases for it. Is a model good or bad? Maybe it's great at creative writing, maybe it's bad at math, maybe it's great at math and bad at creative writing, and that becomes a really big challenge. And we've talked about this with like one for math, the International Math Olympiad, and these kinds of metrics. Why are they important? Why is it important to put it into these sort of human level competitions?
I think the reason we've been excited about these competitions like the International Math Olympiad and International Informatics Olympiad is that they are a pretty interesting example of like a test that is constrained, doesn't require that much knowledge, but really tests your ability to think about a problem hard for an hour or two or three. And we have like a very kind of good we have very good evidence that like these problems are hard. There's a lot of people that try to solve them and compete at solving them, and it matters to them. So I think this is like for models that like excelled at like kind of knowing a lot of things, but not necessarily thinking very hard in the past. That really seemed like the kind of the right milestone to be working towards.
Now, as I understand it, the model that scored gold medal level on that wasn't using like a calculator. It wasn't using other tools. It wasn't using some of the frameworks. It was doing it purely through reasoning. Yeah,
that's right. For the International Math Olympiad, the model was not using other tools. And that was like 2 years ago. You ask it to multiply two 4-digit numbers, it would fail. Yeah, but definitely like for this kind of contest, it's really like it is of course like in a limited domain of math, but it really is about like fairly creative thinking, not about applying a formula.
I guess that's part of the challenge though, is that once you start moving outside of math, it gets to be harder. You can start to come up with things like humanity's last exam, which I think is a pretty neat test, but you find that certain models, after they learn a certain kind of tool use, kind of figure out maybe sort of how to solve these problems better. And I would wonder, what kind of benchmarks are we going to need? What are you looking at to say, okay, this is how I can kind of get an objective measure of a capability?
One thing that surprised me in the past, I was talking to one of our coworkers here, Anna Makanju, and I was telling her about IMO. I was excited about like some progress, and she's like, "What's IMO?" And that kind of like it was like a very important moment for me, because I do realize that like some of those benchmarks we kind of live in a bubble a little bit. Mm-hmm. For me, that competition feels important, and especially like the computer science counterpart IOI, because it was a big part of my life, and so it's true for many coworkers here. But actually, like for an average person, like working in other field, or maybe not as interested in mathematics or computer science, maybe they're interested in history or something.
Anna speaks like 5 languages too, so I could see for her a different metric based on that would be interesting.
Yeah. So I think like one thing that like it's not a perfect metric, but it at least helps keep us honest and helps keep us escape the bubble is just ChatGPT usage, right? Because everybody uses ChatGPT and they use it for all sorts of use cases. And obviously there's like a lot of pitfalls to using that as a metric, but at least it avoids that particular problem where like there are just some things that I'm more familiar with and other people might appreciate other things, and this gives you like a very wide coverage.
Yeah, and in there too, you have subsets of users, people who are building GPTs and doing more complicated stuff. You mentioned before too the fact that the model will reason longer, and that seems like a very interesting way to evaluate capabilities.
Yeah, and I think this is also maybe like one challenge with focusing on kind of usage of like ChatGPT and broad adoption of AI as the metric of progress. Like I think this hasn't really happened to a very meaningful extent yet, but I think it will start happening pretty soon. We should be able to use vastly more compute than a user would normally be willing to buy for themselves to produce technology artifacts that are useful to a lot of people. And I think that for me will be a very important measure of progress.
Which of these wins were the most surprising to you?
I think we definitely kind of anticipated getting to this point when we saw the reasoning models starting to work. At the same time, I think this like recent state of things is very impressive. I think maybe out of those, I think IMO came a little bit sooner than I expected. IMO Gold again, like I think IMO Problem 6 will still. IMO has like all of the problems require like creative thought and some new insights, I think, but typically like there's this proverbial problem 6 that is like requires very out of the box thinking, and it's really kind of like usually like outside the kind of typical domains of the other problems. And so in the past we were actually kind of drawing a boundary between like getting a gold, like solving these other problems, and like actually constantly solving all the problems, and in particular problem 6. So it was pretty hilarious in some way to see ourselves and also Google DeepMind at the same time. Like, oh yeah, we solved problems 1 through 5 perfectly, and we didn't make any problems on problem 6. I think that kind of makes that challenge pretty clear.
Yeah, I think that was what's interesting is that. Yeah, I think that the OpenAI model said like, I don't think I can solve this. It didn't even try, or said that it had a problem with that. Was that correct?
Yeah, the model was able to correctly identify that it didn't make progress on the problem.
That's pretty fascinating to think about that. The model is able to sort of determine that because, there's a lot of conversations about, people talk about hallucination, which I think is a kind of a poorly understood thing. And there's a difference between fluid and crystalline thinking. And one is how much knowledge a model has, and the other is its problem-solving capability. And when you get to the point where it's able to do that, it's able to say, hey, no, I think, I won't be able to answer this. That's pretty interesting sort of point to get to. I've been told to ask this question about a live stream in Japan.
Oh, so I think in the past few weeks, actually, like our models have performed incredibly well in 3 competitions. So we talked about 2 of them, which is IOI and IMO. There is also this competition that is open to everyone, not just high schoolers, called ASCODER. It's a kind of very prestigious, very high quality competition organized in Japan, but open to competitors worldwide. And in this particular contest, it was about kind of longer horizon heuristic problems where you're given only a single problem, you have 10 hours to solve it, and so you have competitors racing to figure out like the best approach to this like difficult optimization problem. So it's a bit different because there isn't like a single correct solution. There isn't like a single pattern to follow. Like these tasks are like extremely diverse, and you can focus on the single task for 10 hours. And so we entered our model into this contest, and to me this had a little bit of a personal significance. I used to be a kind of very engaged competitor in the past in this like more short form, like closed form contests like IOI, and my friend Saiho, who also worked at OpenAI at the time, excelled at this like long duration contest. And when we worked together, he would mock me a little bit that my sort of contest would be automated long before his, because they are the kind of like longer duration, require kind of more focused work. And turns out, like in this contest in Japan, Saiho was actually like one of the top contenders. And so I was watching this live stream, watching our model kind of race with Saiho throughout the competition. In the end, our model actually got second place, and Saiho won. So he alone stood in the way of his his prediction not coming true.
Still 2 wins for OpenAI.
I think one thing that also stood out to me is like Saiho at the end of the competition, he was like really tired, and they interviewed him a little bit to talk about his experience like in the middle of the competition. And I don't think I can quote him directly on this podcast, but he's like, "Your models are very, very bad. I want to go to sleep. I am tired." Yeah.
We've heard talks about like the wall. We mentioned that before. And I think it was interesting because reasoning kind of came out of nowhere. I mean, there were, hints of stuff, some papers and stuff, but people really hadn't kind of drawn the line. Then all of a sudden the O1 model comes out, and the whole idea that you can not just have a model give answers, you can let the model kind of have an inner monologue, talk to itself, and solve things through. Do we think that's enough to take us to AGI? Or are there other breakthroughs needed, or are there just other breakthroughs you think are going to happen?
I just need to point out that like the team here worked extremely hard on this particular thing, and it feels like something simple, like just need longer chain of thought, but like actually to make it work was really hard earned. And I do think, like, back to your previous question of like what was the surprising result when we first noticed that it's working, or we first noticed that we can train those models and give them more data and they get better. That was like, I think, one of the most kind of shocking moments, the moments where we are like, we started asking like very, very seriously the question, like, are we ready as an organization for incredibly fast-paced progress? Like I remember there was like one particular evening, like I think 11 p.m. Like there was like, I think we were on the line with Sam and Mira and just kind of trying to. I think we got a little bit freaked out by those results. Sometimes that happens.
The pace is fast. I mean, it is a fast thing, and like I said, the joke is people, if nothing happens for 6 weeks, they think it's slowed down. But then, if you look year over year, it is. And I mean, it's a fair point because you have things that you're aware of internally when you work on something for a couple of years, and there's a research paper, but it's like, it's not like it came out last night. It was like there's a lot of work onto it. But I'd say the world was sort of surprised by the fact that there is this really fundamental new way to sort of make these models do even more, to take kind of the existing sort of infrastructure, so to speak, and get a lot more capability out of it. Where do you think the next breakthroughs are going to happen?
I think one thing we always try to not underestimate is the importance of scaling. I think, even as we look at these reasoning models, like it's not like, the previous scaling paradigm of pre-training has vanished, right?
Mm-hmm.
Like I think we will see these things compound. And I think there's also like new directions that we can move in. In particular, we were talking about, extending the horizon that these models can, plan for and reason in. And I think if you look at it from the perspective of just like compute spend, we say, okay, we went from GPT-4, which was doing some amount of compute for every answer, to like, GPT-5 Pro, which maybe uses, I don't know, like 10x, 20x, I don't know, like some non-trivial, but in some ways not that impressive amount of compute more, right? And can produce much better answers. I think on the scale of like what amount of compute would you be willing to spend on a problem that actually matters to a lot of people, right? On like progress on a medical research question, progress on developing the next generation of models, right? Like these are like incomparably larger amounts. And so I think that question of like model persistence and ability to work for a very long time on a focused problem is a pretty clear next step.
How would you put the practical implications of AGI to sort of like if we were talking to a typical ChatGPT user or something, like what would their experience be like in a few years from now or 5 years from now, which sounds far away, but it's really not, because which is 5 years ago, GPT-3 came out and that feels like a blur. What would an AGI like model be capable of?
So I was talking about automating research. My picture of how that would actually look like is, imagine a company of very capable researchers and engineers that is largely automated, right? And now again, like I think that is something that like, will interface with the world in all sorts of ways. It won't be just like kind of a black box. Like it will, talk to people. It will kind of like take in inputs. It will run experiments. But I think like, having this sort of potential for developing new technology and other kind of artifacts, code bases, designs. I think kind of like radically accelerate the pace of technical progress. So I think that is something that like we will feel, and when we need to do a lot of work to get it right, from a technical and from societal perspective. But I think that is kind of where it turns. I think we should also expect like a lot of progress on the actual kind of interfaces to AI that we interact with. We see like ChatGPT can feel quite human-like. We can form attachments with it. I think as it becomes more persistent, as it becomes kind of capable of expressing itself in like different forms and text, right? Like I think that those effects will become stronger, and again, like that will be something I think will become a very big and important conversation.
I just got access in ChatGPT to have it actually read my calendar in Gmail. And I realize like how far we've come, because I'm excited about that now. I'm not really terrified that it's going to start writing like, Ewok fan fiction to somebody, and I think that's sort of this neat threshold that we sort of cross this sort of the level of trust.
I think there's definitely like we are in a place where there's like very tough trade-off, where like there's like such clear just economic, personal value you can extract out of having the model, have access to a lot of your all of your data. At the same time, I think like we are not at like the threshold of like robustness where like like we can fully trust these models to not be exploited by someone trying to exploit them. It's definitely like a big problem. I think we as a field will have to iterate on.
What would you tell two versions of you guys today in high school? What would you do if you're visiting your old classroom? What would you say right now? Tell them about the future. What advice would you give?
Invest in Bitcoin.
No, I mean today, even today. In 2025, what would you tell a high school student?
High school students today? Oh yeah, that one is also, I think, a great question, right? Because I hear a lot of kind of what I consider misinformation on that online. So you should absolutely learn to code. One skill that is at premium and will continue being at premium is to have really structured intellect that can like break complicated problems into pieces, and that might not be programming in the future, but programming is a fine way to acquire that skill. So are other kind of domains where you need to think a lot. So don't let people tell you that you should not learn to code.
Yeah, I learned to code late in life, and that's actually, I ended up working at OpenAI as an engineer. And I try to explain to people, just because a system can do the thing doesn't mean you don't want to know how it works anymore. And as you said, when you understand how to break down a task, when I worked at OpenAI in prompt engineering, my coding understanding helped me understand to take both language and break it down and make it do better things. And I think that people who bridge those gaps are really an advantage. And so whenever I hear people say, like, don't learn to code, it's like, do I want an airplane pilot who doesn't understand aerodynamics? Like, this doesn't make much sense to me.
Well, thinking about how I thought about things in high school, I think it's like pretty incredible, like how many kind of perceived constraints are not actually there when you really think about it. Maybe like the first revelation to me was like, hey, if I really kind of like am passionate about this computer science stuff, like I can actually spend a bit more time on it at the cost of, maybe spending a bit less time on like other 12 subjects in school. But then somehow it like, again, like took kind of like it was like a big revelation to me that like actually, I can go and, study in the USA at some point. And like, that's not really something that like seems, that's like obviously interaction space and, and obviously kind of like, like spending some time here in Silicon Valley, right? And kind of seeing like how, people are willing to really like attack these big problems with ambition and like the kind of and the belief that like you can actually make a meaningful positive change in the world. I think it has been incredibly inspiring and and something I cherish about this community.
Is there a book or something that like inspired you?
I think there's a couple of books. I remember it's actually very hilarious. Like thinking about it now, I didn't really connect the dots, but my dad gave me this book once when I was like in a pretty, I think I was like 15. I was like pretty unsure what I wanted to do. It was a Polish version of a book by like some author I didn't know called Hackers and Painters. It was actually Paul Graham. So I guess like again like kind of like this community. I found that pretty inspiring.
Yeah, there's something helpful, I think, to hearing the message of like, no, it's okay to dream big and go do stuff, that you can just make things happen in the world. And I think that the more people realize that, kind of the better the world gets to be. Was there any book that influenced you? Or movie, TV show?
Oh, movie. I have a stupid answer to that question.
I love stupid answers.
Bad after the profound one. But like, okay, so I watched Iron Man.
Yeah.
And it inspired me to start a PhD in robotics.
That's a great answer, though. Like, The Martian by Andy Weir, I met a scientist at NASA who was a botanist who read that book. And I'm like, well, they got the atmospheric physics wrong and all this. He's like, well, it's why I'm here. I'm like, oh. Well,
I guess I didn't get to the stupid part. The stupid part was like, when I started working on robotics, I was very disappointed how bad those robots are. I somehow didn't occur to me that like maybe the movie is a movie. So that whole experience was kind of bad for me. Would be kind of bad for me if not for the fact that I like met a friend who was into deep learning, and at the time I thought all of the machine learning kind of is a hype, but it was an interesting systems problem. And then out of nowhere, and as I'm sure like I would frustrate some DeepMind folks by saying that AlphaGo came out. No, I'm sure it wasn't out of nowhere. I'm sure it was years in the making, and that like was very inspiring. I actually think to both of us, and since then it was just hard not to work.
Yeah, it took me a while to become convinced that deep learning is more than a fad, because like we don't really understand the kind of underlying optimization, and I think this kind of has been the story of our research here, trying to make progress on these questions, like about how it really works, but it really is like studying a physical phenomenon in some way. And to a classically trained computer scientist, that was a weird thing to accept.
Mm-hmm. I do remember when Jakub was telling me about like scaling up principled convex optimization. Like, that was before AlphaGo.
we did, and AlphaGo was interesting because first, like, oh, cool, it solved Go. And then we're like, yeah, but it just learned by watching all these. Then they did AlphaGo 0, where it's self-taught. And you're like, okay, game over, folks. There's a trajectory here. And I think that's continued on. But I think that, if you hadn't watched Iron Man, maybe Thor instead, maybe things would have turned out better.
Who knows?
No,
I kind of wish I studied maths instead. Has been more useful.
Studied what?
Maths.
Maths?
Mathematics. Or
Okay,
theoretical
yeah.
computer science. Either of those. Like this, yeah.
Physics probably is that.
Oh, physics. Physics.
I started off as a magician. None of you know that. So I actually had my own reality TV show. And so you find a very strange path to end up here. So, Jakub, Szymon, it's been an absolute pleasure to talk to you both. And I hope we can meet again and talk about the next big breakthrough that you guys have been secretly working on that's going to come out of nowhere. And we'll be like, oh, it's an overnight thing.
Thanks, Andrew.
Thank you.